Well, I don't know if you've seen GPT-4 Vision, but the thing was very interesting. I started seeing some examples over the internet, and I came across also this other model here called LLaVA. So it's developed by another group, and seems like their paper was even published in April. So it's been a little bit because things are being published so frequently. And today I just want to check it out and check some examples as well. So follow me. So what I see here is the GitHub page for LLaVA, and here you'll find a bunch of things, links to the paper, and also the model that they keep updating. There you'll find the link to this page, which has both of the papers, code, the demo, and the dataset that they used. This here is the first paper that they published, so in April. And the thing about it that they claim here is that their model is a lot smaller than the other ones that do similar things. And the performance is just very good. So state of the art stuff. But one thing that I was curious about is, okay, so what's the architecture that they use? And that is the main thing here. So it's interesting that the architecture is not so complicated when you read. They use this vision encoder here in the beginning to transform the image into the vectors. So just like if you're used to the language models, you'll know that you have to transform your tokens into the vectors. So this encoder here, this vision encoder, is used for the same thing. Then you have this projection, it's simply a matrix that transforms those vectors into another set of vectors that is used as input into your language model. And this language model that they use in this paper is a llama language model, and the vision encoder is this here, the clip vision encoder. The interesting thing, both vision encoder are pre-trained, so they got off some other group, and the language model as well. So after putting those architectural parts together, how do they actually perform the training? So they perform in two stages. First one, they freeze everything but that matrix. So that matrix that transforms the output of the visual encoder into something that will be ingested in the language model. And they also freeze the language model itself. So you train that until you have satisfactory error. And after that, after training, they go to a second step where they freeze the visual encoder and they update the weights of the projection matrix and the language model that they use. After that, they also published another paper. So this here, it's fairly recent. And the changes that are described in this paper are just three. So they use a different encoder. They use a multi-layer perceptron projection. So instead of only a matrix, they put a couple of more layers there to perform that projection. And they add more data to train. And you can see here, well, their results are outstanding. So let's try it out. This here is the example that they make available. So they have some preloaded things here. So what's unusual about this image? Let's see. So the unusual aspect of this image is that the man is ironing clothes while standing on the back of a moving car. Very unusual, that's for sure. I got also some examples here on the internet because I wanted to try it out to see how it performs. Okay, so I got this one here, which is this meme. So the image is a comic strip featuring a man standing in front of a broken picture frame. So it describes the panels. Finally, in the fourth panel, the man is holding the frame in front of the crowd, possibly showing them the broken frame. So, well, it understood it, the general concept, but it didn't understand also the specific thing here about like bugs. So it's not a bug, it's a feature, right? It's a detail there, but the model's interpretation is amazing. This one here is interesting. I've seen some examples with GPT-4 Vision that someone would give like an electronic circuit and it would describe and even the components and so on. So I decided to find something on the internet with some components and see what happens. So the image is a diagram of various electronic components and their functions. A wide range of resistors, capacitors, inductors, and other components, all labeled with their respective names. So overall, it's impressive how we can even understand here there are some components that, well, let me know if you want to try something else, or let me know if you tested with something that you find is amazing. I really recommend that you try this tool here. I think these things are the future, these multimodal models. Yeah, it is impressive. Let's see what the future holds for us.